Hi, welcome to the Spatial Data Science community call. I'm Andy Eschbacher. I'm a data scientist here at Cardo, and I'm here with Taylor Oshan. And we're going to interview Taylor today about some of the emerging trends that he saw at the American Geophysical Union conference about a month and a half ago. But before we get started, I wanted to talk a little bit about some of the logistics for the call. To organize our call, we have a Google Doc that anybody in the community can edit so that we can organize better. If you go to the last Spatial Data Science newsletter, there are links right by the link to this Hangout to the doc that you have here. And under it, within the doc, there's a section for roll call. And if you just put your name, your affiliation, and your Twitter handle if you want, totally optional, please put those below. And if you have any non-verbal updates that you want to share, we'll share those afterwards if you'd like. If not, we can just leave them there for other people browsing this document. And then if there are any upcoming events that you want to list, so these could be conferences, it could be talks, webinars, anything like that. And then for the next call, we're going to do calls once a month. And so the next one we're planning for the end of June. So you can go to the document and see more information about that there. And then if you want to tweet at us, at the top, the @SpatialDataSci is our Twitter handle, and we'll be monitoring that for any questions or anything like that that you would like to contribute to today's call. Okay, all right, so let's get started. Like I said, this is Taylor Oshan. He is a PhD candidate from Arizona State University. He is defending his thesis in October. Okay. And he's at the Geographical Sciences and Urban Planning Lab or Center?
School,
sure. There, and he was recently at AGU. And talking beforehand, a lot of trends in geographical data science. And so our community is built around spatial data science, or traditional data science, but with, or traditional data science, but with spatial component and how these two fields are emerging. So what are some differences between geographical data science and data science that you've seen?
Sure, yeah, it was interesting because this year at the conference, I think it was the first year they had sort of a track devoted to geographical data science. So I spent quite a bit of my time at the conference attending those, and those were both research talks and then also panels. Mm-hmm. So they had some sort of similar themes and concerns, and so it's an interesting question of the differences between GDS and DS, data science and geographic data science, because it's not really a new question. So there's always been this question of whether or not in spatial statistics, spatial is special, and maybe in geography and quantitative geography as a whole. So it's kind of a question that kind of comes up again. And so I think one of the differences from the spatial statistics point of view that's been argued, and I would continue to argue, is that spatial data have their own sort of quirks that have to be handled when you're using them. So you have things like spatial autocorrelation, and we say spatial dependence or spatial heterogeneity, so how different processes are varying over space. So you don't necessarily have to worry about any of those in data science. And then in fact, you see data science applications on spatial data where they don't account for these things. And depending on the application, it may not matter, but it may be actually very important to the kind of insights that you can pull out of the data itself. So I think that there are probably other important differences, but I see that as a very clear one that you can essentially inherit from the field of geography.
Mm-hmm. So how many of the techniques that you saw at AGU were just adaptations of traditional data science methods, and how many of them were kind of novel ways of bringing two the different methods together? Did you see much of that, or?
Yeah, it's certainly a mix. I mean, I saw, for instance, my own session was on sort of analyzing vectors and movement. Okay. There was somebody adapting the dbScan algorithm, which is a pretty well-known clustering algorithm. Mm-hmm. For vectors. Okay. And so, I mean, that seemed like it was ongoing sort of research. I'm not sure it seemed like, I'm not 100% savvy with the DB scan sort of statistic in itself because they do more inferential stuff. But that seemed to be one where they were taking like a very clear sort of data science method and applying it to more geographical concepts. There was also some work from outside of geography. There was one presentation on clustering. So it was taking more of an applied math stance on the problem. And I think that there are probably lots of parallels to the more classical regionalization and region building algorithms and what was presented there. So that was kind of interesting to see like a perspective that was totally outside of geography and maybe even typical data science as well. So there's definitely, I think, all sorts of flavors there within data science, within geography, and something that's coming from neither of those things, but aimed at, I guess, representing both of them.
Yeah. Cool. And so that's kind of on the like the analytics side. On the data side, like what role has like open data played?
I think a huge role. Yeah. So in my own work, I mostly use open data, which I find more stimulating because you have information about the data, in some instances less, but you can share the data. So when you do an analysis, you can then push that data out and have your analysis checked if anybody is interested in doing so. But of course, the fact that there's open data means there's more data. So I'm interested in questions of, we have these sort of classic geographical hypotheses where there's certain variables we pop in, like population as representativeness as an attraction of a place. But we have so many new interesting things we can use to represent attractiveness now due to sort of open databases like in New York City, where you can, or open street maps where you can just pull out all sorts of points of interest. And so I think people are using them, but there's still a lot of work left to see how that differs from sort of more classical census variables.
Have you seen any trends in the use of like open GPS data? Like New York City taxi data set is a classic example that's used. It's like data, like, it's like a data scientists use it a lot, like for demos and stuff like that. But like, are open data sets like that where people are doing pull requests to get this from city agencies? Do you see any trends in those sorts of data sets?
I mean, the major trend is that it's definitely being used all over the place in geography. Sure. Yeah, I mean, I saw it. It was in my own talk. I was using it. Another talk in my session was using the taxi data specifically. I think I saw it at the GI Science conference in a poster. Somebody had used some of the taxi data. And so you see it for exploratory stuff, visualization. You see it for inferential statistics. You see it for more data science types, like the whole sort of, I think, collection of data science and geographical tools.
Nice. And then what about like size of data? Because like, for instance, like the taxi data set's something like 40 gigs for, I don't know the size, but it's something like 120 million points, pickup and drop off locations for like 1 year.
Yeah.
Have you seen the scale of data that people are tackling and using these geographical data science techniques change more, and like the tools people are using? Yeah,
I think for some instances, like I think there's a few relatively well-known visualizations of that taxi data where you can really quickly pull out the trends. And I know that requires quite a bit of databasing work to be able to query all of that data all at once. And then I think there are other instances where it's not as clear that all of the data is as helpful if you're looking at it all at once. So for instance, I remember this clustering algorithm was, if you have that much data, you can almost find a cluster of vectors if you're including all of the time and assuming it's basically cross-section, if you're not accounting for the time differences. You can pretty much find a cluster anywhere. So I'm not sure how helpful that is in those circumstances. So that's where I think a lot of new ongoing work is sort of defining the questions that you're going to be asking more precisely so that you can then have more precise analysis that follows that. But that's where I think, yeah, for the big data stuff, I think there's a lot of, or open data, and more of it is, there's been a lot of cool demonstrations, but I think that's where you can get a lot more deeper insights of the analysis of starting with a more specific question.
Another thing we talked about was how does the geographical data science differ between academia and industry there, and like what are the different roles that it plays between the two?
Sure. Yeah, this was a topic on one of the panels. I think it's kind of, I mean, it's definitely a concern of academics, what their role is in all this, and then also what they can sort of expect or can't expect from the industry side as well. So I think one of the big things that the theme that came up for academics is specifically for geographic data science as a newer subdiscipline is we need to be involved, because if we're not involved, we won't get to ask the questions that we think we have responsibility to answer.
Mm-hmm.
So, I mean, we have the luxury of being able to ask things that, don't build a product every single time, that kind of stuff, or looking out for privacy and that kind of stuff. And so some of those issues are particular to the geographical side. And so if there's not a geographical data sciences, then those concerns will not be met. So that's sort of more just within the realms of academia, not particularly being involved with industry. But I think another role was, I think a lot of the advances are coming from industry. A lot of industry companies have research components where they're inventing new algorithms and making things better. And so one of the concerns that academics have is if any of that will be released. Obviously, not all of it's going to get released, but some of it, and if it can be replicated and used by others. And so I think there's a large overlap in the roles that both academia and industry play, but also those differences. And so, and it's nice to see sort of bridges between the two, so that where there are overlap, they can work together.
So, like one thing I definitely know that industry collects way more data and has that proprietary.
Absolutely.
You've seen it on the algorithm side as well.
I think that was more of the sentiment that I was heard. I don't have the experience to know that in terms of industry stuff, but I think it's expected that, or people believe that, like oftentimes they'll take a more generic algorithm and potentially make it better, whether it's with the express desire to do that, or it just happened to be a necessity in a new product to be able to deliver it to people. It's got to be faster or more scalable, that kind of stuff.
Cool. Was there any talk about like a concern over using things properly or getting improper insights from some of these techniques? Yeah,
I think that was kind of this role of the academic thing that people were highlighting and saying, because some academics might say we don't need the term geographic data science. We have geographic information science, we have GIS, we have quantitative geography. So we have lots of other titles that are probably overlapping. And then people who were more pro geographic data science as its own distinct subdiscipline were arguing that if we don't protect these concerns, so this idea that if you're doing inferencing and not accounting for dependence, you might have incorrect inferences, which could lead to not incorrect policy, but inefficient policy. Or things like privacy, sort of sampling of data and how you release it. So those are things where I think every now and again you hear about some things that happen in the industry and they never seem to be on purpose, but there's sometimes oversights, whereas in academia people may have those concerns front and center.
And then, like, kind of going on the geographical data science being a subdiscipline, and there are all of these other subdisciplines. Do you feel like the communities are talking well, or do you and cross-pollinating, or? Yeah, I think it sometimes is a touchy issue, just because it moves so quickly. And right when one subdiscipline seems to become well-known, there's a new catchier title. And I think they do largely overlap, and I think it is important to rebrand. If you've got new things that you're incorporating, you might as well market and promote those things. And I'm sure it's helpful in terms of getting funding and sort of advertising what it is you do and staying relevant. And so I think I've been to a few conferences where this has been argued about, and so I think it's important at the end of the day to probably be like find itself. I say whatever I think the audience I'm talking to will most understand. I like the term geographic data science, but if I
know someone that doesn't know what data science is, then I can say I'm a geographer concentrated in quantitative methods. I think it's good to be flexible in that sense, but I also agree that there's enough in geographic data science to be calling its own sort of sub-discipline.
Yeah. How do you see, kind of like as a philosophy, how does the philosophy of geographical data science differ from like traditional GIS?
Sure. I see geographic data science as being more encompassing. So for me, I use, in my own research, I can only speak to that, is I use GIS as a tool within sort of statistical research. So GIS is not always encompassing of that. Sometimes it's actually limiting in terms of getting things into the way that the statistical algorithm works. So sometimes I enjoy the little bit more of the generalizability of the data science perspective, but also just the organization of the information. So in geography, clustering is obviously a big thing, clustering of polygons, clustering of points. So for me, the concept of like unsupervised learning and clustering segmentation is a natural comparison, but one that I didn't learn in any GIS class. So for me, I'd like to learn those things all together because I can draw these parallels. So I see sometimes as the data science being more general, and it can be sometimes easier to start there, or at least encompass all of that and then become more specific. Whereas if you are just focusing on GIS, you may never get to the point of inference, or kind of shut out some of those machine learning algorithms.
So I was listening to NPR last night, and there was an advertisement for a company that does machine learning and artificial intelligence. Did you see trends like that for geographical data at AGU?
I didn't see any advertisements I wasn't aware of. I think there are certainly companies, but I'm not always sure how their focus, because I think that there's a lot of companies who probably maybe are doing some geographical data science or consuming geographical data science, but they don't call it that, or it's not their primary focus. So yeah, I don't know. I think that's an open thing. So, yeah.
Cool. Let me see. I think those are most of the questions. Do you have anything that I didn't ask that you'd like to wrap up?
I have one that we had noted that I don't know if we went over. So some cutting edge trends.
Oh, okay.
Yeah. I think the obvious ones are sort of scaling, and then scaling and inference. So a lot of scaling and sometimes entails shortcuts. But if you take shortcuts, it might have large implications for how you do inference. So I know inference is not always at the forefront of everyone's applications. If you're just concerned with predictions, then this is often not an issue. But I think that's one that's becoming more interesting. And then for my own research is sort of big models or local models. So where we're also taking in a lot of information, but then actually giving out a lot of information in the form of coefficients or parameters, and then using multiple scales of analysis. So kind of taking the models we have and adapting them so that we can think about different processes of happening over different scales, but all within one sort of conceptual framework. Not having to say, I analyze this separately at this scale, and then this other process at this scale, but collectively at these different scales, these different things interact. So it's an extra layer of, I think, complexity.
Cool. Yeah, I think we've talked about this a little bit before, but there's like, another thing that's very popular right now is like hierarchical Bayesian modeling.
Yeah, exactly.
So it's just like pretty similar to.
I think that fits right within those themes of multiple scales and big/local models. Yeah, it's certainly within that, and there's different ways you can do it. Some where it's the data makes it obvious the way that you do it, and other ways where the question you're asking makes it more obvious. So there's kind of different approaches to get there, and I'm really interested in, depending on the data you have and the question you have, what is the most appropriate model, or if choosing an inappropriate model has negative repercussions, that kind of stuff. So those are more, I think, geographical questions that we build on top of some data science frameworks, whereas in data science, they might not ask those things. It might be more of, we'll just let the data speak for itself type of thing. So yeah.
Actually, so that reminds me of another question I wanted to ask on the difference between geographical data science and traditional GIS. Traditional GIS tools tend to be these like monolithic packages that it would be impossible to incorporate, for instance, like the whole ecosystem of what Python is able to do, for instance, or R or something like that. In terms of like the tool sets that people are talking about, have you seen any trends at AGU or other conferences on what people are using? Like, are they moving away from these kind of monolithic systems and trying to put together their own workflows?
Yeah, definitely. I think that's a sort of data science or geographic data science trend. It's really flexibility in tools because the whole thing moves so quickly. If an algorithm is available in R, but you usually use Python, having that flexibility of not having to code it yourself in Python or wait for it to come out in Python is huge. So I think that building your own workflows and adapting workflows, kind of that hacker philosophy, is I think necessarily embedded in the data science, geographic data science sort of ethos. It'd be hard to do it without that. So I think it's hard for one monolithic package to capture all of that. So if you're always waiting for the new thing to come, by the time you got access to it, there might already be another new sort of data science tool. Yeah.
And then kind of related to that, are you seeing more people in academia participate in the coding community, like on GitHub, or like they have some very specific novel analysis that they did? Are they the ones to code it up, or did they get like their graduate students to do it?
Yeah, I mean, it's definitely becoming more often. And so for the previous sort of question and this question, I can mostly only speak from my own experiences, but I happen to be fortunate working with a lot of colleagues that do code their own stuff and do make their own workflows and then also share all of that. So it's kind of that free and flexible thing where someone's like, hey, I did this cool thing, you know, do you want to check it out? Sure, yeah, can I use it? Yeah, no problem. And it makes, I think, being able to collaborate on stuff a lot easier. So you don't have to figure it out yourself and then say, hey, we both do this, let's collaborate. Someone can just say, oh, you're interested in this, let's share this, and we can both contribute towards it. So I think that's been like super helpful, and it's definitely the attitude I've had with everyone that I've been able to collaborate and work with during my research.
Cool. Yeah, I know that's essentially how we met.
Yeah, exactly. Yeah, exactly. So I mean, I've been really fortunate to work with people who value that and put effort into doing that. So I mean, I think it's a growing thing across the board. Yeah,
for sure. Yeah, cool. Do you want to share any of your research or what problems you're thinking about right now?
So I mean, I guess I sort of did just very quickly. It was that multiple scale stuff and the local models. That's definitely the main thrust of my thinking right now. So my dissertation work is actually not local models. It's spatial interaction. For now, it's not local, but looking at more issues of how you account for spatial dependence in flows, because they're vectors and they're not points or polygons. They have extra dimensions to them. And so how you measure relationships between them, and then how that kind of ripples through inference and hypothesis testing of exploratory statistics and sort of regressions. So that's kind of one thing, since I'm finishing up my dissertation now, and then the other is the local models, like you said, hierarchical scales, multiple scales, hierarchical scales, and then how you can extend the basic regression framework for that. So it's one thing to be able to estimate the model, but then to be able to learn from that and sort of make statistics-based decisions and that kind of stuff requires quite a bit more development. Cool. Yeah.
Thanks for sharing.
Yeah, thanks.
Cool. So we're gonna see if there are questions that we should ask really quickly. Okay. No questions. There are a couple nonverbal updates. There's, I'll just mention this one. So somebody posted on NYC Open Data, they're interested in data sets on human dynamics, for example, individual tweets or check-ins, and that I could use for my research and that are not on the Open Data platform, I'm assuming the NYC data portal. Anybody would be interested in sharing, please tweet at tweeting_CRIS, tweeting_CRIS. And then they've collected aggregated Foursquare data and they'd like to talk more. Cool. All right, so I think we'll wrap it up. Thanks for joining us, and look for an announcement in our upcoming newsletters about the next community call. Thank you. Bye.